Hi, welcome to our math. Today I'm doing a series of videos on inequalities and graphing inequalities. In this video, I'm specifically graphing a system of equalities. So what I'm going to do is this first system, both of my lines are in standard form. And the way I'm going to graph these are with the intercepts. So for 5x minus 3y is less than or equal to 15. I'm going to put it equal for now. This is just for the graphing. I'm going to say, hey, if x is equal to 0, then negative 3y equals 15, and that happens when y is a negative 5. 1, 2, 3, 4, 5. Then I'm going to say, well, what happens if y is 0? If y is 0, then 5x equals 15, which happens when x is equal to 3. Okay, now I have to go back to my inequality equality. There's an equal sign there, so I'm going to do a solid line. All right, now I have to figure out where to shade this line. So I'm going to test a point, and I'm going to test 0, 3. So is 0, 3, does that satisfy this inequality? Is 5 times 0 minus 3 times 3 less than or equal to 15? Is negative 9 less than or equal to 15? That is true. So that means we're shading on this side. I'm doing a very little amount of shading because I have two lines and I have to get the shading for both of them before I figure out what region actually is shaded. Okay, for my next line, I'm going to do the same thing. For the 4x minus 6y is less than or equal to 12. I'm going to say, hey, what happens if x is 0? If x is 0, then negative 6y is less than or equal to 12, or y is less than or equal to negative 2. Again, treat that like an equal sign. Negative 2 is right here. All right, well, what about if y is 0? Well, if y is 0, then 4x, 12x works with 3. So it doesn't matter with inequality equal sign. Here's our point of intersection, which we'll get to in a minute. There's an equal sign there too, so this is also going to be a solid line. I can test the same point, this 0, 3 again. So my question is 4 times 0 minus 6 times 3 less than or equal to 12? Is negative 18 less than or equal to 12? That's true. So that means I shade over here above the line. So my final answer for this system is they intersect at the point 3, 0, and the shaded region is this section, which is on top of both lines. All right, let's try the next one. The next one, my first line is in slope-intercept form. I start at negative 5, 1, 2, 3, 4, 5. My slope is 3 over 4, 3 over 4. I like doing all of the points because in a lot of cases, one of these 4 points is going to be the point of intersection of the two lines. Not always, but in many cases. All right, this is going to be a dashed line. It's dashed because there's no equal sign here. So I'm going to dash it out with arrows. And for this one, I'm going to test 0, 0. I'm just going to test that origin. So is 0 less than negative 5? And I just did negative 5 because 0 times anything is 0. I don't need to write a 0 term. Is 0 less than negative 5? No, that's a false, which means I'm going to shade below this line. Okay, for my next line, my y-intercept is negative 7. 1, 2, 3, 4, 5, 6, 7. And my slope is 1. Remember, there is an implied 1 here. So 1 over 1, 1 over 1. There it is. All right, it's a solid line this time because of the equal sign. So make this solid. And for shading, I'll test the origin again. Is 0 greater than or equal to negative 7? That is also true. So we will, or in this case, it's true. So that means my answer is this little sliver between the lines, and my intersection point is 8, 1. Something like this, if you didn't put all the points out and you're not positive, double check. If I put in an 8 here, 6, 1. If I put in an 8 here, minus 7, 1, that point is a point of intersection of these two inequalities. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.